In this lesson, we are learning about prime factorization. So first of all, to review the term factor pair, we know that 2 times 5 is 10. So that means the pair 2, 5 is what we call a factor pair. So when we find factor pairs of numbers, for example, 18, I know that 1 times 18 is 18. 2 times 9 is 18. And 3 times 6 is 18. So those are the 3 factor pairs. Moving on to 24, we have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And then for 51, we have 1 and 51, and 3 and 17. And as you can see, they would each then start over. So 1 times 18, 2 times 9, 3 times 6. We can work our way back up this way, 6 times 3, 9 times 2, and 18 times 1. Those are all called factor pairs. So in this word problem, the brass section of a marching band has 30 members total, and the band director arranges them in rows. Each row will have the same number. So what we're trying to figure out is how many possible arrangements are there. So what we want to do is find the factor pairs of 30. So the factor pairs of 30, we have 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So how many possible arrangements are there? At first glance, we would say 4, but we can do 1 row of 30 or 30 rows of 1, 2 rows of 15 or 15 rows of 2, 3 rows of 10 or 10 rows of 3, and then 5 rows of 6 or 6 rows of 5. So physically, they would look a little bit different. So there's actually 8 possible arrangements. So now, let's say the woodwind section, different section, same marching band, but they have 38 members. So now our question that we're going to answer is which has more possible arrangements? Is it the brass section or the woodwind section? So we're not just looking at the number of band members, but the number of arrangements as far as rows, equal number of rows. And then we're going to explain that answer. So now we're going to find the factor pairs of 38, just like we did 30. So for 38, we have 1 and 38, and then we have 2 and 19. And that's it. So there's only 2 factor pairs. So if we look up here, there are 8 arrangements, but over here we only have 4 arrangements. 1 group of 38, 38 groups of 1, 2 groups of 19, and 19 groups of 2. So we would say the brass section has more possible arrangements. And that's because 38 only has 2 factor pairs. You can put that in your own words if there's another explanation you like better. So only 2 factor pairs or 4 arrangements. Okay, flipping to the back side, we have some new vocabulary words. Now we're going to look at what's called prime factorization. And this is when we take a number, a composite number, and we write it as a product of its prime factors. We use something called a factor tree to find our prime factorization. And then you know your factor tree is complete when you only have prime factors in your product. So you get down to just prime factors. Basically, you can't divide it anymore. Okay, so in this first example, we're going to write the prime factorization of 48. So to start, we can choose any factor pair of 48. So when we are working with 48, we have a lot of options here. There's a lot of factor pairs. So I'll show you a couple different versions. You can choose any factor pair. So to start with my factor tree, I'm going to take 48, and I'm essentially going to make branches. So it's kind of like when you make a family tree, you have branches to all of the different members of the family. We're going to do that now, but just with factors of 48. So I could start with 3 times 16. Okay. 3 is a prime number. I can't divide it anymore, so I'm going to circle it so I know it's done. And then I'm going to keep going with 16. I can do 2 times 8, or 4 times 4. 2 is a prime number, so I'm going to circle that one. Can't divide it anymore. So I'm going to go on to 8. My only option here is 2 times 4, circling the 2, and then 4 times 4, circling the 2's. So since I'm left with all these prime numbers now, that factor tree is done. Let's look at another example. There's always different ways that you can create your factor trees. So starting with 48, this time I'm going to use 6 times 8. Okay. 6 can then be divided into 2 times 3. Both prime numbers, so I'm circling them. And then 8, 2 times 4, 2 is a prime number, so I circle it. And then 4, 2 times 2. So you can see that they both look a little bit different, but we should end up with the same product in the end. So if I look at these, I have 3 times 2 times 2 times 2 times 2. Same thing over here. I have 1 3 and 4 2's. So your prime factorization is always written as a product. And then we also want to simplify it and write the smallest number first. So what that means is I have 4 2's, so I'm going to write that as 2 to the 4th power times the 3. And there's only 1 3, so I just leave it as 3. So that would be my prime factorization of 48. Go ahead and pause your video, and I want you to try 88 and 90. Remember, you can use any factor to start with. So if you weren't quite sure of the factors, for example, 88 you know is an even number, so you can do 2 times whatever that factor would be. 90 is also an even number, so you could start there. 90 does end in a 0, so you know 10 and 5 are factors that you could use as well. So go ahead and pause your video and try those on your own. Okay, and then on this last one, I'm going to get you started, and then I'm going to have you finish this one as well. We have this class that ended, and there was a student that didn't finish finding the prime factorization of a number that they were working on. And their first step was 8 times 24. So the first thing we want to do is figure out what was the original number. Well, if we look at prime factorization, we're always starting with a factor pair, so that those first two numbers, when you multiply them, give you your original number. So to find the original number, the first thing you're going to do is find that product. That will tell you what your original number is. Then you're going to finish finding the prime factorization. So you're going to take that original number, start with that at the top, okay, and then you're going to put your first step. They used 8 and 24, and then just continue from there until you have your prime factorization.